Okay, I'm in the final exam review page. Let's do some review for your final. So first off, I've got this list of topics. These are the all the things that could be on your final. So knowing the order of a DE, knowing whether a DE is linear or not, just like we had on test one. This is the one people always forget about. We had one lecture video on autonomous DEs. They're super easy, but people forget about them. Like, go back today and rewatch that lecture video on autonomous DEs. I'm telling you, it's going to be on your final. Like, here's an example of an autonomous DE. Autonomous means your derivative only depends on your dependent variable. Y prime only depends on Y. We're not trying to find all the solutions to an autonomous DE. We find the equilibrium solutions, the ones where y prime equals zero, and then we sketch out a slope field based on that. Again, just go back and rewatch that lecture video. Make sure you know how to solve separable DEs, and we can have those in a couple forms. We can have them in like differential form, where everything in front of dx only depends on x, and everything in front of y only depends on y. And we would just integrate all three parts. Don't forget, when you put an integral over here, you have to have a dx. Or we could have the kind where we multiply by dx and get all the y's on one side, the x's on the other. Exact DEs. Remember, the solution to an exact DE is capital F of xy equals c. You don't stop when you get your capital F. The final solution is junk equals c. Linear DEs. Remember, I'm kind of a pain about how I want you to write these up. You find your integrating factor, multiply everything through by it, write the left-hand side as the product rule derivative of y times the integrating factor, integrate both sides. Remember, every single time in your life that you write the integral sign, you better have a differential to go with it. We had homogeneous DEs. That's where we find our characteristic polynomial. Those are pretty easy. And then we had the harder version of that, the non-homogeneous ones, where you have to find the YP. This was all test two stuff here. Of course, we'll have some initial value problems. Laplace transforms, you will have a Laplace transform table on the exam. You will not be asked to actually solve a DE using Laplace transforms. They just take too long. Yeah, mathematically, they're easier because we're turning a calculus problem into an algebra problem. But there's just so many places where the algebra can go wrong. Remember, like test three, you have to go through and do your partial fraction decomposition and all that. Like it's kind of a pain. The only questions I'll ask here about these two topics is just doing a Laplace transform. I'll give you a little function, say find this Laplace transform, or I'll give you the Laplace transform and ask you to find the inverse. And you are given a Laplace table. We'll have some systems of DEs that can include reduction of order, like where we start with y double prime and we turn it into a system, just like on test three. Go back and look at test three, but no repeated or complex roots. Those are a pain. Absolutely could have Euler's method, but nothing like too complicated. You only have to do like a couple of steps. I wouldn't ask you to do like 10 steps of Euler's method in a timed exam where you don't have access to technology. Yes, you could have to graph a slope field like up here with autonomous DEs. Power series, like anything here we're doing on test four. And you know, with both of these, Euler's method and power series, I like to combine problems together. Something where I'm like, here's a DE. Let's find a couple of points using Euler's method. Now let's actually solve the DE and get the actual solution, and let's see how good that approximation was. Same thing with power series. And then the Wronskian, if I give you a set of possible solutions, asking are those independent or not, and if they are dependent, finding a linear combination that equals zero. Okay, so that's the list of topics. That'll make more sense. I don't know what happened there. If we look at these in context. So, like, here's an old exam. Here are a bunch of old exams. Look, here are three or two more finals and more solutions. There are some myopen math practice tests, a whole bunch of review material for you here. It's taking a while to load. Let me download it. I don't know why it keeps doing that. I'm going to refresh this page, so it'll stop doing that. Okay, let me just download this and then open it. Okay, so this is an exam from just a couple of years ago. Your exam's going to be pretty similar to this. Here I'm talking about an autonomous DE. So we set the right side equal to zero. We find our equilibrium solutions. Those will be horizontal lines. And then we do a sign chart to see if our other solutions are attracted or repelled by these equilibrium solutions. Again, go back and rewatch that lecture video on autonomous DEs. I'm telling you, it's going to be on your test, and it's one that people forget to go back and look at so they don't know what to do. Here we've got a homogeneous with constant coefficients, DE. This is a separable DE. Notice right here, when I just integrated everything, I made sure to put a DX over here. And the antiderivative of zero is just C. Here we got a different kind of separable DE. We get all of our Y's on one side, all of our X's on the other. Make sure you read directions whether the question asks for implicit or explicit form. Explicit means Y equals junk. This would be the implicit form here. This would be explicit. Like anything that says leave your answer in implicit form, it's probably because it's impossible to solve for Y and get Y equals junk. So don't bother trying. If it says leave it in implicit, you're done. Okay, this was an exact DE. Notice my final answer is junk equals C. That's a place where a lot of people miss a point. Linear DEs, like literally everything you see here is what I expect for a complete solution. Oh, okay. Yeah, this we're looking at an old exam here and there was a typo in it. There was supposed to be a Y right here. So what I've done here, yeah, there should be a Y right here. This is the solution to the problem I meant to write. There was supposed to be a Y right here, which means there should be a Y right here. This is a separable DE, the way it's written. So you would move this to the other side and then just integrate. This is the solution to the actual problem. This is the solution to the problem I meant to write. So what you should practice is put a Y right there, which means we'd have a Y right here. And this is how we solve a linear DE. Okay, solving IVPs, make sure you know how to do that. This again was a linear DE. So we find our integrating factor, multiply everything by it, write the left side as d dx of y times the integrating factor. Integrate both sides. Do not forget, every time you write an integral, you better put a dx or whatever your independent variable is. Okay, here we have a non-homogeneous DE, so we're going to find our YPs, a nice pretty system of DEs. Say, this is what I was talking about before. Or I'm asking you to do Euler's method. And then in this particular case, this old semester we're looking at, I just gave them the actual solution and said, okay, let's check how good that approximation was at one. I could just as easily say, okay, now you solve the DE. Problem is, this one would be kind of ugly to solve. I guess it wouldn't be too bad. It isn't linear. Okay, now we're doing a power series. Just take your time on power series. So many places you could goof. Make sure you read the directions because I'm going to ask for like the first 4 or 5 terms. That doesn't mean we're going up to say t to the fourth. The A0 term is the first term. The first 4 terms only goes up to t to the third. And then we're comparing, just like I said, I would probably do the actual solution with our approximate solution, our power series solution, and seeing how good the error was. Stuff like this with Laplace. So I'll give you something and say, okay, find the Laplace transform, use the provided table, or find the inverse. Just make sure you practice some of those. Linear versus nonlinear, finding the order. That was the first thing on the list. Checking the Wronskian. And like this will be your provided table. Okay, so your test is going to look a lot like this. Here's here's another old one. So a couple different old exams there. Let's take a look at this one. It's going to look pretty similar. Look, equilibrium solutions to an autonomous DE. That particular semester, I didn't say graph the slope field. I would probably ask you to graph the slope field. Like, try this on your own. Make sure you're getting all the same solutions. I wouldn't do this anymore. Like, look how much work that was right there. Yeah, I just think it's there are too many places where the algebra can go wrong. And then how do you grade that when it's a take-home exam like we've had in this class? You got plenty of time. You got technology you can use to do your partial fraction decomposition. I think this was a take-home final. What year is this from? I don't know. A nice system of DEs. Yeah, try all these on your own. I absolutely would not do a repeated. Yeah, this is definitely a take-home final. In a timed environment, I would not give you a repeated eigenvalue. And then power series. Yeah, a lot of good stuff in here. Okay, I think that's a good place to stop.